So, what are Thoughtboxes? In short, Thoughtboxes are a category of MCP server that provides structured, navigable workspaces for LLMs to think in. They give the AI some general-purpose tools for thought and some context on how to use them. So instead of dumping all of our agents' reasoning into a linear token-to-token stream, we give LLMs a way to structure, revisit, and potentially revise their thinking. Thoughtboxes share 4 characteristics. First, they have architectural structure. These are organized patterns like numbered cells or thought entries, branches, hierarchies, and so on. They provide agents with cognitive affordances. Thoughtboxes enable an AI to use certain reasoning modes like branching and comparison, revision of previous thoughts, and verification against sources of truth. Next, they provide process orientation. Thoughtboxes scaffold the process of thinking. And finally, Thoughtboxes provide addressability to steps in the reasoning process, stable references for nonlinear navigation and in-flight editing. So why do we need Thoughtboxes? What pain points in our lives as agentic engineers do they address? Well, as we've already touched on, LLM reasoning is trapped in a linear transcript. By default, an LLM has few or no means of noticing what it's thinking until it's already finished generating output. And this makes it expensive for an LLM to correct its reasoning. The AI has to look at its previous output, trace back through its reasoning, decide where things went wrong, and produce a correction with all of the bad reasoning still in context without any tools to help it along in the process. To help us visualize what this looks like from the agent's perspective, let's do a little thought experiment. Imagine that we're writing an essay, and we want to outline that essay so we have a good idea of what we want to say before we start writing. We can imagine 2 approaches that we could take to do this. In the first approach, we could think out loud to a friend taking notes on our stream of consciousness, and in the second approach, we could use a storyboarding app. Now let's imagine how the first approach would go. I'll be the person writing the essay, and you'll be my friend taking notes. I might start by saying, my first point in this essay is X, and then I'd rant and spitball for a few minutes about what I want to say in the essay about point X, which will open the essay. But then it occurs to me that I should actually start the essay with point Y, not point X. So I stop mid-rant and say, wait, no, actually scratch all that. I want to start with point Y and then start going on about point Y while you scribble in a notepad trying to keep up. How much fun are you having at this point? Probably enough fun to say, screw this, I'm out, right? Now let's imagine how the second approach would go. In this scenario, you'll be the person writing the essay, but because you're more efficient and organized than I am, you're outlining that essay by using a storyboarding app. Just like me, you start out thinking that the essay should start with point X, then write some note stream of consciousness into the app. Then, just like before, you suddenly realize that the essay would be better if you started with point Y. But this time, instead of making your soon-to-be ex friend keep up with you while they scribble notes into a notebook, you just create a new slot in the app, call it point Y, and rearrange it on the screen. No frustration necessary, and you keep all your friends. Why is the second approach clearly so much better than the first one? Well, at its core, it's because the first approach is costly. It is costly for you to parse through my verbal corrections and try to connect what I'm saying now to what I said before in a way that makes sense while you scribble in a notebook. You spend a lot of mental energy to do that because the modality is not navigable. You'd have to travel back in time to some checkpoint in my verbal spitballing session to correct the record because the record is being created after the fact. You have to hear what I'm saying before you can process it in your mind and put it on paper. In contrast, the second approach is cheap. It is cheap for the storyboarding app to implement our corrections because our modality is navigable. Our points have addresses from the moment that they're expressed. So you can just swap the addresses of 2 points, or you can go in and directly change the information that's held at a certain address. So in this way, we say that Thoughtboxes are tools that make it cheap for an agent to iterate on its own reasoning. Now that we've covered what Thoughtboxes are, I want to define what Thoughtboxes are not. Thoughtboxes are not service connectors. They aren't wrappers for another service. This doesn't mean that Thoughtboxes can't help an agent use MCP servers that do wrap external services, but as a general rule, a Thoughtboxes functionality does not depend on the functionality of another service. Next, Thoughtboxes are not memory servers. A memory server may store useful information that an agent can use to inform its reasoning, but it does not scaffold the reasoning process itself. Finally, Thoughtboxes are not static templates. They do not simply serve basic data structures like to-do lists, because these structures do not provide the rich cognitive affordances that are necessary for complex reasoning. Thoughtboxes matter because they give agents access to low-cost iteration on their reasoning. They give agents better control over their cognition, nonlinear write-edit workflows, and reproducible thought structures that promote an agent's ability to improve on its reasoning. Now that we've defined the category, the next step is to look at a concrete implementation, the Thoughtbox MCP server. In the next video, we'll see what all of this actually looks like. I'll see you there.